welcome to Coffee Compiler Club. And this morning we were actually talking coffee. Um, Somebody here has got a roaster and is roasting from green beans. And that's a little more hardcore than me. But sounds good. And otherwise, we can talk about compilers too. It's all good. Um, Everyone's been recorded. We show up on YouTube in a few hours. Everyone's heard this spiel before. I don't typically have any set agenda. I know Simon's been working on something that I've also been working on, and so I was going to show what I did and see if Simon can be drawn out to show what he's did. And Yasser is not on, but he's done some stuff that I've encouraged him to go do, and I wanted to go look at that stuff too, but we'll see where we get to. So, let's see, and the Zoom chat says something about coffee, right? Where did it go? It went away because I don't have chat open. Chat says coffee things. Okay. Yeah, so I have very little direct to show, but I have ideas, so I'm going to switch to the Google Docs if I can go find myself. I have to do the share button here, which is hiding. Oh, they changed it again. Holy crap, Zoom. What are you doing? Fine. All right, maybe. Yeah, coffee blends. Let's see here. So now this I can show. Let's see here. What's a good way to do that? I'll just bring up some examples here. Um, oh, and in fact, Zoom got a bug out of that. Oh, they left they left a button that is on top of my desktop over my Emacs that belongs to Zoom and not anything there. So let me get a test case up here. So I've been doing functions in simple. And I've long thought about this kind of stuff in the context of AA, and I've kind of decided I'm going to do the same thing in simple. So here is a sample function definition in simple. Pardon the gruesome layout issues from you know what? Where is code extensions? Get this started. Just so we can start here. And let me do it. Maybe. It'll help, not much. Um, so a function opens with a curly brace, then has type arg, comma, type arg, comma, type arg until you hit an arrow. And then you have a function body. And this is simple syntax. This works right now in chapter 18 space. And then, you can call it by loading up just a local variable. That's just a local variable. Um, and then it happens to be a function pointer. So you can make a function call by putting parens and args. So it's a very classic syntax. But the difference here is that var sq is just a normal, it's just a normal function. I mean, sorry, just a normal field, normal variable. There's nothing special about it in any way. And I can use, function type syntax if I want to explicitly declare, but if I just do var or val, it'll just infer the type, and the type will be the obvious function of int to int. And then you run and you do your thing. So it's just a function. So that part's straight up. Then we got structs in simple. So you say struct, oops, s has some stuff in it. Let's put some stuff in it here. I don't have strings, but let's pretend I have strings. And I'm going to do int age, just whatever. And then somewhere in the code, you would say, make a new S. And because I'm going to do, I didn't specify that these things need to be initialized, but name is not declared mutable, so it's immutable. It's a ref pointer, so it must be now declared in the constructor. Illegal to have an immutable, not null. It's immutable and not null. And therefore you must assign it in the constructor. Arg, you can take the default of 0 if you want, or you can assign it in the constructor. So fine. And now I've made a struct s, but let's put it in a variable. We'll call it person. And here you go. Fine. So then the next fun thing that Simon was talking about and I've been looking at here is I'm going to put a function in here which is going to be something like uh, whatever is majority, age of majority. It's the wrong term for it here. And this is going to be a function that takes the self pointer, which is the structure in, and I don't have any syntax here, so I'm making up dot, but it could be anything, plus some args. And I don't have any extra args for this one. And it's simply going to return, arg is greater than or equal to 18. And then you would call it by saying person dot is majority adult, do whatever you're going to do. And the thing that goes on here is that is majority is just a field lookup. Just do a field lookup. Oh, that happens to be a function pointer, and it's well typed as a function pointer. So if you put arguments after it, you get a call. And if you don't, you get a function pointer. And you can pass function pointers around in simple, just like they're a first class value. And then you make a function call. And the only change here is that the function pointer gets a hidden this argument. So the act of doing a struct dot field with a function pointer gives you this pointer as arguments to an immediately following function. And actually, it's going to curry. So as soon as you say person.isMajority with a function pointer, you're going to get a function pointer that's going to be curried with person. And you'll have a function pointer that takes the remaining arguments that isMajority needs, which is none. And then you can call it at any future time. So this syntax has the sort of, the concept here for me is that I don't have separate function calls or function call syntax or methods versus functions. It's all just the same thing. And I don't have separate functions as a function declaration. You just say var and it's a field, and then you assign it a function value, and it's inferred what its type is, and away you go. So there's nothing special. So I have one fewer things to deal with both the syntax and semantics and execution. It's just a field lookup like every other field lookup. Let me see if I can format and do something change-wise. It's not terribly helpful. Fine. So that was sort of the new game I'm playing with here. New in the sense that like other languages don't appear to be doing this kind of a thing. And then there's a performance hack. You say, oh, it's a field. It's got a function pointer in it. Every struct has all function pointers for all things. No, there's an obvious performance hack that's under the hood. It's a performance hack. And you throw all the constant final fields. So I said var, I say val here. I say val, it's a final field that's declared in the constructor or in the initial class definition with a constant, which is a function pointer constant. Then those can be hauled off to one side into effectively a hidden prototype class and accessed that way. So when you say person.isMajority, I would go to the person's prototype class, pull up the majority field, which will be a function, and then make the call as normal.
But looks like arg is captured inside the function, but it's captured only locally inside the scope.
So this is the reason I don't have any syntax here is that actually I was intending to put the capture by demanding that majority takes a hidden argument, the this pointer, and he's going to call it like this is a description. This is not allocate any storage or make an object. It's just a description, right? It's a type.
Mm-hmm.
So this is actually a hidden, call it self. There's a self arg. So you don't have to say self, you're in scope of arg, but you get a hidden self.arg and it gets passed in. And it gets passed in at the time that you do a load of person.majority. So somewhere down in here, val fun is person.isMajority. I don't have any completion here.
So you can tell the thing you're looking for here is the field on self simply because arg was never initialized inside the function?
It's because you didn't declare an arg inside the function. So you go function scope, it misses, doesn't find the name, goes out one scope, finds struct s, finds arg. That's where it comes from.
But as we spoke, we simply wouldn't support closures that capture something
Yeah,
inside.
right. So, well, be careful here. So there's a couple different kinds of closures, and what
Yes.
this one doesn't require me to have stack frames that are heap allocated. Now,
Mhm.
having said that, I am busy making the evaluator, in fact, run with closures. So I'm
Yeah.
going to get to a point where I can run with closures and experiment and see if I like, and if I actually want full closures or just stack only, in which case I'll start denying things where you escape out of a scope.
Can
Here,
we have it halfway and is capture only inside the current scope, not inside the class, but let's say here.
well,
And
there's no real capture. This is syntactic sugar for self dot, and I take a self arg, which is a
okay,
type S. So that
but
was just syntax sugar for doing that, right?
mhm, mhm.
Right, but how is that not just functions defined inside of a struct, close over the struct?
That's what it
That seems
is.
like that's exactly closure.
Oh, I see what you're saying. Well, no, here the implementation. Okay, here's the difference. The implementation here doesn't require me to heap allocate stack frames. The this the self pointer, the this pointer, has been
Mhm.
previously allocated by the new. Like the programmer wrote new. He made
Yeah.
an object. Well, I'm just going to take it using the same mechanics as a closure. Save myself on another implementation of a separate thing. In fact, my closures in the evaluator are the same as my continuations in the evaluator, are the
Mhm.
same as function pointers. It's all just the same thing.
We could say that this is only the scope that is majority can capture values from.
Yes, but he actually can capture outside. That requires, I'm just going to write the one without the syntax sugar, right? This is this is what you wrote. Sorry, I'm catching up from my thinking over here. Okay. And
Mhm.
then and then we could capture outside. As soon as we capture outside, I have to deal with a real closure.
Yeah.
So, right? So I could say here, and then somewhere down in here, I would say, oh, whatever, greater than pi, right? Now
Mhm.
I've captured pi from an outer scope.
Yeah.
Now I actually need something. Okay. So as long as you're still stack oriented, I'm willing to implement this.
Mhm.
As soon as you need to be heap oriented, I want a syntaxically obvious way that you can write code that you know you're getting stack frames, that I can optimize it to stack frames and life is fast, but you're allowed to write code that escapes things, in which case, you admitted by the act of writing that code that you were going to break. So here is an example.
I mean, this sounds very similar to me to what people did in early JavaScript when there weren't yet classes. You would just write a constructor function that made a function that had all the variables in it and then had a bunch of functions in that scope that you returned from the closure.
Right. I am totally heading for classes here that you could throw into a module system or import or whatever, but the first implementation says that you could write a class like thing in the base language. Not that you can't have a canonical, well-defined way, but there's no extra semantics to the canonical, well-defined way. It's just normal, simple code. So here is and I want to have arrow and an int count, which it can default to 0, but I'll fill it in to be obvious. I'm going to return, and I'm going to return a pair, and I don't have pair syntax in simple. I could get there. I don't have tuple syntax in simple yet, but totally could happen. Um, pair of functions, one of which uh, one of which returns the count, one of which increments the count maybe first and then returns it. And then I have an A counter. This generator generators counters, right? And then B generator And then if I do a print a dot zero, which is a function, which I'm going to know our function I'm going to call, and it should print a zero. And if I print, a dot one, which is the other side of the generator, should print a one. But if I print, B, he's not impacted by A. And then if I do, B dot one and B dot one a few times, and then I can print, you know, B dot zero times 10, oops, to get the digits different, times A dot zero. And I would expect it to do what, 21 here or something. So this guy clearly returns a capture of count, right, outside the scope of the function. He needs a heap allocated stack frame, which includes count to have someplace to store it. It makes multiple different counters. And of course, to make my syntax short, this already works. If you have no arguments, you don't need the arrow. You just can do that. Yeah. So the theory now is, how do I write the code? How do I define the syntax? I guess I should close my guy here. How to write the code such that you can tell when you're writing one of these functions and know that you're about to get a heap allocated function call with its associated costs. Or I'm going to give it up and say, hey, I'm not going to do closures and this becomes a syntax. I guess if it becomes a syntax, I'll just look at it and say, no, you returned this function outside the scope of its declared function. And that means I had to capture this guy and I'm not going to do it, neener, neener. Here, it's not the same thing because I'm passing it in explicitly, even though it's under syntax sugar, it's being passed in explicitly. Here, I would need to pass in the missing stack frame. And I said generator, yes.
I may get the syntax wrong because I don't do a lot of C++, but don't they have something where you have like arguments that are explicitly captured arguments rather than args that came in the normal way?
Yeah, yes. So that's what I would consider that a compromise that says we don't want to do this the hard way, so we're going to put some syntax down that says we're going to capture this, which means that you had to have allocated still at some point.
Right. Now it lets me do the thing that is slightly obnoxious, which is to say, if I don't tell you what to capture, I'm going to capture whatever. But if I explicitly tell you to capture nothing, now I'm guaranteed that I'm not going to get a heap allocated frame because I told you to capture nothing.
Right, but I claim that should then declare syntax error, count not found.
Yes, at that point, it would be a syntax error because count is not found.
Undefined variable. Yeah, I hate that syntax.
And so there's this question of, do you want people to be explicit when they're allowing things to capture, or do you want people to have to be explicit when they're forbidding things from capturing?
Well, the usual story is you want people to have the sort of least surprise and easiest effort writing, and Cameron's point, always easiest effort reading. I claim that the capturing, in my head, the capturing syntax has no surprises on what it means, but it has surprises on its performance.
Right. So usually what I would want is to not type that.
Right.
But have it sort of appear in gray that my editor's like, hey,
well,
by the way, there was an implicit capture right here.
Right. So the editor
and if I double click on that, then it fills it in and says, okay, well, now you're being serious and explicitly stating it, and you don't let the compiler pick. But that when you let the compiler pick, you just let your editor be like,
oh, right. I claim that as soon as you say I have an IDE to fill out the syntax for me or otherwise change it, the language becomes not ASCII, but the language becomes some dynamic ASCII as edited or confused by the IDE of choice, whatever that means, which doesn't work for all possible IDEs everywhere. and then you still have this syntax that has to show up at some point. I'd claim I don't want to write the arg. How do I get gray out of this? I don't want to write arg either. Pin, split, table, comment, more actions. Where is, it might be under format. How'd you get that color? Somebody got gray color there.
I believe it's the A with a line under it,
I have an A
next
with a
to bold
check
and
mark.
underline.
Oh, way over here. Text color. Fuck. Which color did you grab? Just straight up gray. That's close enough. Yeah, I don't want to write the arg there either, because in my head, the default is do what I say, which is grab count and hand it around. And then I'm surprised that performance is the cost of a stack allocation when I call generator. And maybe I shouldn't be smacking around, but this example is so simple you can't tell. As soon as you get something big and complicated and you start throwing nested lambdas in, you'll capture by mistake. Java will come along and say, "Hey, it's not a finally," or whatever they call the special term that says,
Yeah, and I've definitely seen lambdas that capture shockingly, where suddenly you make this little tweak and the entire game board is in your monster.
And of course, then there was the Go bug as well, which we accidentally copied in ecstasy, where
oh,
it would capture the loop variable by reference, and because the lambda was deferred, it would when it would actually run the lambda, you'd only see the exit value from the loop for all the iterations. Here, I'll post a link.
I'm about to go see if I can pull it out from memory. I've seen this bug before.
Yep.
Yeah, Python has a flavor of that too, where you build 15 lambdas, each with a different constant, except actually you build 15 lambdas, each with a reference to the same memory location.
Right. Okay,
I
put
think
in
C#
chat.
has made the same mistake.
Let me
It's an easy mistake to make.
yeah.
Unfortunately.
Implicitly
go.
capturing this pointer also.
Right. Here he's capturing the V out of the iterator with the function internally. And you're imagining you're going to get a different value for V every time. But in fact, he makes a function out of this, calls go, 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 and throws out 3 function pointers, bang, 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 into go routines. The function pointer grabs the final value of the variable, and there you go. And you get CCC instead of...
Yeah, the current value of the variable, if you will.
Yeah, the current value, yes, the current value of the variable, which is by the time this execution happens, you've already exited the for loop. So the current value is the last value on the way out. Or if your scoping of V is not visible, I'd say that variable didn't even exist after the loop exits. What the hell? Okay. Now the question becomes, what would you rather do? What is the least surprise, and how does that fucking work?
Yep.
This says you don't capture the variable, you capture the value.
So what we did is we changed it so we always capture the value by default, even if it's not a final,
right,
in Java parlance. But then we allow you to explicitly capture a reference by declaring the variable as
you had like auto or volatile or something.
Volatile, I think. Yeah.
Something funny. So that's a version of int I equals 0, I less than n, I plus plus, and then delay. So, new Java code here, new thread of run of print I.
Right. And in Go, that would have always printed n.
Yeah, right.
A lot of n's.
Right. Right.
Yep. Well,
and this is closure capture, right? And this is why I was thinking I didn't really want to capture this closure here.
Yeah, and actually with the new thread, all bets are off, I guess, because it could be anywhere between 0 and n.
Yeah. I'm starting them on the fly to go. But if I just capture the functions here,
Right.
and I get a bunch of function captures, am I
Right.
capturing by value or am I capturing by
And it turns out,
variable?
unfortunately, even though it looks like you want to capture kind of the live value, what you drop the live and you'll be happy here, right? So you
Right.
want to capture the point in time value here.
And when I do for loops, I give you another scope for I, and then it becomes, while I less than n, I plus plus. This is the syntax sugar for loop blown out. So that
Sure.
down here,
Right, but I can't. So on the one hand, I can't think of any obvious way to make it obvious what you have captured
right,
without explicitly writing them all out. But the minute I say you have to explicitly write them all out, that becomes really annoying because it's like, okay, well, should my function capture all of the things that I imported at the top? Like, do I need to recapture
right.
the cryptography functions? Like,
Like,
No, you capture the things that are named in the closure.
yeah, they're named right here.
So one way to do it, if you're the approach that we took compiling the lambda is to do the first pass through the lambda as if it's part of the code that contains the lambda. So at that point, all the names are local variables, and it's like, oh yeah, I know what that is, and so on and so forth. So once the scope closes on the lambda from the first pass, we know all the captures at that point.
Mhm.
And then based on that, we create a function that includes those captures as explicit parameters.
This
Uh,
is the Java finally hidden syntax sugar. It's a finally variable they can
something
capture.
like
Yeah,
that, exactly.
right.
And then we bind those, then we
But
bind
when you
those.
when you call the function later in life, somewhere down in here I say funds of rand, and I call it, and I want to
Right,
print. What am I printing now? Well, when I called the function arguments right here, I didn't pass in I.
right, because you already created a
Oh,
basically a trampoline.
you go ahead and curry it on the spot.
Right, because that's the only time we
Gotcha.
have the value. That's the
That's a
only
better way to
place.
think about it.
Yeah,
This is effectively something like I made a function of no args, which is going to call the prior guy
right, exactly.
with the known value of I at the time.
so if I actually want I, what do I have to do there? Ampersand I?
What did the word actually does have no meaning here. So you need to put
If
that
I
in.
would like all of my functions to reference the same memory address, an
Make them
object that gets
closer.
mutated and is shared mutable state
Right,
between things that are potentially in different threads,
right.
because I
Yeah.
like foot guns,
Then you should make it explicit, is the
So,
argument that I would
then the
make
thing that
based
I put
on
there is ampersand I, or
I don't,
well,
in
Cameron said
Cliff's.
volatile.
Yeah, so I think we ended up with volatile as the as the keyword, or at volatile, I think it is actually, but yeah,
okay, so
because
merely the fact that I didn't mark it as volatile means if it tries to be accessible in that way from multiple different
Right.
right.
executions, it'll
So it
just
defaults
balk
to
at me.
capture by value. Exactly.
Ah, okay.
And up
So
here in the generator where I definitely want to capture by reference, I would have to have some syntax that says capture this by reference if it's used inside of a closure.
yeah, and the best thing to do, I think, is to review all the discussions around the Go mistake, because there
Ah,
were good discussions around that, explaining why they did it the way they did it, and then how it blew up on them. So
right.
you can learn a lot from other people's mistakes. I wish I would have seen that before we made the same mistake.
C Sharp fixed this in 2012.
Yep. C# had
How
the
did they
same
fix it?
bug.
They made a mistake way earlier already.
Well, I'm sorry. Yeah, C sharp, but they made a mistake, and then how did they fix it?
They just changed the meaning. I mean, it's C#, right? It's like
Yeah, there's no
not
backwards
that backward
compatibility.
compatibility is a
Yeah.
big important issue for
Gotcha.
them.
Backwards compatibility in C# used to be measured in weeks.
Gotcha. Gotcha.
Right. So if I was like super early programming languages, they would just put a prefix and be like, only variables that start with this letter are allowed to escape their scope, and only
Well,
variables that start with this letter are not allowed to escape
I
their
think only
scope.
Fortran did that. IJK.
Yeah. And specifically, though, to be fair, nobody had this functionality except maybe Lisp. You know, like, and I don't
Well,
know.
Lisp has its quote and unquote.
No, but I don't know if anyone actually was capturing mutable references until Self or Smalltalk or something.
Right.
That came
And
much
then
later.
Lisp would do this because they were closures from Get. Oh, were they closures
Right,
from
right.
get-go?
But
might have been.
they were, well, this is where we need
Right.
Haley. But yeah, I think they were closures over constants. I don't think they were capturing the mutable references, were they?
Well, you had. I'm thinking that they would effectively had a stack frame always heap allocated as just another cons array. So all stack frames are heap allocated, so immediately you could do that, except that they have to have a bang operator. Like in Scheme, it was called set bang. But as soon as you used set bang, you could see that you had a closure and you were modifying the shared variable. So the set bang meant that you didn't put anything here, you put it here. At the mutation site, you couldn't do a straight up mutation per se. You had to say set bang, comma, new value, right? So count plus one, if you will. So it wasn't that you modified the description of the variable, you modified where the variable was used. And then if you couldn't tell where the variable was going to get used, you just had to assume it was always going to be set bang. And then the implementations all didn't care because they were always running, hey, we're doing full heap allocated frames at every step. So step bang has no extra cost. It just is, it's the red flag. You see set bang, oh, and here's my foot gun.
So Python has a keyword for non-local to say I'm defining this variable, but I'm defining it to be whatever you found out of the scope of this function.
Um,
Doesn't feel very AA-ish.
Right. In AA, I just said if your first reference to a variable is a set, it's a local, you just declared it. And if it's the first reference is a read, it has to be found in some scope or it's dead already. And if it's found in whatever scope it's found in, that's the scope it's in. But you don't get to set a non-local variable first up. You have to read it once, and then I know you're referring to the out of scope variable, and now you can set it.
That's what I was wondering. Does it make sense to have some kind of syntax for saying this is a non-local variable
Right.
that is always optional, but means
Yep.
suddenly if it is a local variable and you just declared it to be non-local, that will be a compiler error that just gives you the ability to write a hint to other developers that this variable is intended to be non-local.
So here's the AA
So like the
hint.
very first time you say count, you just be like,
Yeah.
some syntax indicating non-local count.
Yeah. That means non-local because I'm going to look for count. I'm going to find it non-local. Actually, that's not a bad answer.
Right,
like
but I
that.
have to look for it.
Yeah, I'm
Like
just going to look
in
for
this
some.
syntax, I actually have to look at the function and be like, hey, did this come from somewhere?
Oh, can I get rid of the grayness? Yes. Ah. Oh, I said I got rid of the arrow because it was syntax sugar. You could argue that you like the gray to be there to let me know.
To tell you that the arrow is optional.
Yeah, arrow is optional. Right. And so the first time I look at count, yeah, okay, there you go. There's a non-local syntax that I can like it's totally optional and seems reasonable. Turns out that plus plus count or count plus plus also does a read. That's just syntax sugar for count equals count plus one, which reads first. So right-hand side does a read immediately. It's non-local.
But do you think that's obvious to someone who's looking at the code?
I'm
I mean, it's
getting
obvious in
there.
this function, sure.
Yeah, right. This function's so simple. In the land of closures down here, I am printing I. As soon as I printed I went out of scope. I'm referencing the out of scope, but oh, I see. But it's not, no, this is a different problem. What you described was when do I make a local variable and when do I reference an external one? Here I'm reading the external variable, but I want to capture it at the time. I want to treat it like a local variable and capture it at the time.
Right. That's Lisp's unquote.
Lisp's unquote.
In Lisp macros, they have quote and unquote.
Uh, oh yeah, right,
You want to be like, hey, I'm in the middle of this capture thing, but
right.
what I actually mean
I'm
is to do
sort
this
of in the zone.
evaluation at def time.
Right, yeah, right. I'm sort of in the thought of I'd rather have ampersand there to mean I'm capturing I by reference as an ampersand as opposed to the volatile keyword just like too much bulk for me. I'm like, oh come on. And it does have the advantage that it's at the type declaration point, which means immediately you can tell there's some code generation issues going to happen at the point of int I, like I has to be treated special. I is not going to be in a register. I is going to go on a stack frame as a memory slot that someone can read from.
Yeah, and now you get to the question of, well, how complicated of an action can you take when you say, I want this action to happen at definition time of this function rather than at execution time of this
Yeah,
function?
yeah, right.
Maybe I want to do something like read a file off of the file system at def time of the function, but I don't want to read the file system every time the function's called. I just want to read the file system once at def time.
Right.
I feel like the real question is here is how do I say for this little piece of execution, do it at def time rather than at call time?
Maybe by default you capture by value and you get what it's high. But if you want to be confusing, you can say var. So that would be
Well, var is the new variable declaration.
yeah,
And it's
but
brand new, so it has no value or whatever. You have to set a value on it. It has nothing to do with the outer I.
yeah.
That's the reason I was going for ampersand and Aaron was saying unquote, and he was saying ampersand too. It's something that
It's
says,
as
hey,
long as it's one symbol, it's fine. So
this is the volatile version, and there's Cameron's volatile has its uses in that it's very, very large and obvious.
mm,
Yeah, right. And then Java does the new local I guy. He says, hey, it's not effectively final. And you go make an effectively final I, and you say final I is equal to I. I do
Right.
that all the
Yeah,
time,
so
right?
and Java
I mean, you
can
certainly
only
could do that, and that's how I fixed my bug when I ran to this thing both in Go and Python.
yeah, Java can only capture final. So
yes,
Wait, Java can only close over final things?
Yes,
yep.
yes.
yes.
That's an
That's
interesting choice.
doesn't right. He makes a copy of the value at that time. That is
And
the local variable I you're looking for. Then when you use it down below in the function, it's known to be goes into the closure, just like somebody was talking about earlier, Cameron.
And the way that I get around that is because I can have a final reference to a mutable thing if I
Yes,
actually need everyone to
because
Yes,
share.
Java has mutability of everything, and
yes.
you can capture finals. So you can capture, yeah,
Like in my generator example earlier above, I would have said, make a new generator. Well, that's my new stack frame with word count, but it's called generator instead of a stack frame and has a local variable int count. And now I can mutate it. Well, right? Here I am, in the generator example, I'm using the stack frame in lieu of saying new generator and generator being a struct. Struct generator has int count, new generator. That's my handwritten allocation, heap allocation, as opposed to an implied heap allocation for having a stack frame. Do I care? Maybe that's just good enough and you're just done. See that's the other way to go here is simply say, you fucking want a new storage location to hold something, just say fucking new and walk away.
yeah. And I think in your language that would be a reasonable approach. I mean, It's not.
I find the at volatile to be like bulky, but so
Yep.
is effectively final. There are many times in my Java code I write, ah, effectively final int.
Right.
Why can't you just take the int as effectively final and leave me alone?
Exactly. Exactly. And the other thing that we did when we made the change after finding the bug, after then realizing we had accidentally reproduced Go's bug and C Sharp's bug, is we then went back and examined all the places that we actually were capturing something by reference on purpose. And it was like 2 to 4 times total in the entire code base. So
Right.
out of a couple 100,000 lines of code, so the number of it's a handy thing to be able to do, but when you're doing it, it turns out it's quite purposeful.
So
And
which
quite purposeful, having to add a nat volatile for something that's quite purposeful seems quite reasonable.
so I would say it the other way. If it's purposeful, you would add a new and you would make a mutable class object. And
Mm,
I hear you. I could
no,
go both ways, except in my head right now, I'm thinking 2 to 4 out of 100,000? Fuck, just say new wad, new thing. And now I
right.
mutate my thing. Okay, I do.
But I don't, no, because it's not just about mutating, it's also about seeing the mutations. So if I make the new thing, then the code actually has to look a lot different because then I have to dereference it to get the thing out that I'm looking at. So it is kind of ugly.
It changes the code. I'll agree. I'm
Right.
just thinking, I don't have a good example here. The generator example
But
is
it
too
changes the
simple.
code in a kind of similar smelling way to how it changed the behavior. On the one hand, the code now has this dereference in it, and on the other hand, you have to get global consistency because those things might have been handed out to different threads. Like there is a dereference there.
Well, I'll talk about multi-threading. That adds a whole nother wrinkle.
Yeah. Yeah. I'm not talking here. I'll paste in,
Yeah, an example would
sorry.
be good. You can go down to the next code
Uh,
block if you want. I'm going to scroll on you.
you can move it if that's not a good place for it. But that's the
That's
annotation.
something happened on the color coding because you have,
Yeah.
and
That
then
was,
you're
I'm
gray
blaming.
on black or white. Light gray
I'm
on white is unreadable, and black
okay.
everywhere is
Let me
not
try
the.
again. Let me try again with the super duper paste there. How's
Yeah,
that,
and delete the. I'm going to delete the prior version.
please?
Right. So you've basically declared a boxed object. You made a box.
Well, what it means is that what we think of as a variable needs to be lifted. Yeah, I mean,
Right. I mean, I could write something kind of similar in Java. It was saying like a class box of T was going to have a T variable T and and you can not
right,
it's not
right,
right. And then
exactly.
there's some get and set on it.
Right. But now you're not using the T, you're using the T dot T, right?
Yes, I'm using T dot T. Yeah. Well, or T dot set, T dot get. Yeah. Right.
Yeah, I think, the number of times that we had to create object holder as a class in Java is, yeah.
I've done this a few times, but not
Or,
very often.
or an array of size one. That was a common one. Yeah, I mean,
I only did that when I had to return stupid things.
yep, exactly.
I need to return two things. I don't want to make a pair, like a new object of, and thing zero is type X and thing zero is type Y. And I have to cast when I pull them out. But I want to do a multi-return because it's complicated and blah, 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 blah. Fine.
That's the kind of
That's
thing I did in Python to
that's an
solve these
unrelated issue.
problems is I made a list containing one thing
Okay, sure.
because there's a bunch of pass by value, pass by reference stuff.
Right, right. Yeah, Java didn't have a syntax to make a tuple. where you just hit print and list some things. And I know I'm going to allocate. Okay, I am. Fine. I want to return two
See,
things. Don't make
that's the
me.
beauty of Python is you can put stuff in a list of size 1 and incur all of those allocations and dereferences, and your code doesn't become meaningfully slower because it already is.
Just one more allocation. No one cares. Good point.
The key to making boxing cheap, make everything else expensive, and now
Yes.
boxing is relatively cheap.
And it's relatively cheap. Yes. It's all relative. When it's all bad in the first place, a little more bad, a little less bad, whatever. Fine. Excellent. Yeah.
There's a lot of APIs that are
So,
much cleaner in Python than C++, because C++ is bending over backwards and giving you 4 ways to do it because are you borrowing it or are you owning it and do you allocate it or do they allocate it?
right. Well,
Python doesn't have
there's a
that
lifetime
mess.
management going on in C++ as well. That is another unrelated aspect of things. In the land of what I'm going to do with simple, I'm going to have to stare. I definitely don't want to make the Go mistake. Um, so that turns around and says, in this kind of a thing where we have the volatile, or we're looking at one, I'm going to highlight these things where these are all various options of dealing with the fact that I want to get at the guy by value and not by reference. Volatil's the other one. It says, I want to get it by reference, so I'm complicated and thick. Final, effectively, final I is I want to get it by value, and so that's the default, but I have to be thick. I have to write syntax on it. I don't want to do that. The ampersand version of things seems pretty minor, and it's like the shortcut for volatile, which means the default for local I is, we'll go back to local I, it's just get I by value. This is me coming up with what I'm going to do with simple as a language spec.
So what does it mean if I put ampersand I in the spot where you have I right there?
Right. And then if I, in the outer closure, let me go ahead and fix the alignment here and see what's going on. And then ampersand would be like using the volatile keyword. I have to come along. I have to think if I want to do that syntactically because I do code gen of the IR on the fly, and I would like to not have to go recode gen upon discovering a late arriving ampersand. Some references to I are and some are not captured. What do I do? Like in the effectively final solution, I had to change names and it was just illegal to use I. So it didn't matter. In the
So if you were
volatile
doing a
one,
very much run from the top to the bottom parsing, you could just say, hey, if the first one didn't have an ampersand,
absolutely, absolutely. And
and
then
then a
the second
late
one,
ampersand shows up, that's just a compiler error.
that's just compiler. Yeah, right. And that's maybe where I end up going. Yeah. Yeah, yeah. First reference has to say ampersand to say,
Or you could say all references must have the ampersand.
and that would be the other one. And that gets a little thicker if you're using I a bunch. But if you're using I a bunch and you're doing a sign, so I guess actually the ampersand has this funny syntax
Is
issue.
it possible though that sometimes you want to capture the value and sometimes you want to capture the mutable reference?
You can you assign it? You can assign it.
Then you say
Yeah.
star ampersand.
No, you just put an assignment further out. Right, you just capture it in another variable up here. This is your
Also,
effectively final version.
if it's not confusing enough, if you capture by reference, and suddenly the value changes.
I claim I
You
could
don't
do
know
it this
what.
way, Cameron. I would say I've made a new variable outside the function called II. That's my capture by value. So I think I'm not far away from being able to get that. The thing I was looking at was, does this impact crap like I plus plus or plus plus I? Um, maybe not. Weird is weirdly there. I could also put demand this.
It's even more confusing.
Yeah.
supposed to be.
Well, the confusion here is what you're trying to accomplish. Although the generator is exactly doing that. This is what the generator's doing,
Yeah, yeah, fine. But
right? Here,
yeah,
here, because I can choose which way I want the count to go. Oops. Let's do. I could do this without any trouble.
okay. But here, what do you want? You want first you
Yeah, exactly.
increment and
Right.
capture the reference, or you just want to increment the
The,
value and then capture them?
this gets into. I wrote it in the generator up there. It's like the ampersand goes with count. So syntactically, when I'm parsing the syntax, I see a plus plus. I know I need to see a left-hand side value or it's an error. I see an ampersand that goes with the left-hand side value. Now I find count. Now I have a left-hand side value. It happens to be out of scope. I'm capturing by closure. The actual implementation will be whatever the word for declosuring is. There's a word for it, functionalization or something stupid, where you actually get a function. It takes a closure as an argument, and that's the stack frame of the prior guy, and he's going to bump it. He's going to take that as an argument. So it's ultimately, hardware doesn't do this. So syntax sugar happens, and the syntax sugar is you got a hidden stack frame as a bonus argument.
Cool.
I guess we could argue our way to would. I'm trying to think. I have to ponder implementation wise here, but hidden. And we don't want gray. Yes. Okay. So you have dollar stack frame, and then this becomes stack.count, which I totally accept. That one, that's fine. And then
What's with
here,
the
this guy
dollar sign?
has to be done by reference as well. So you have to put the ampersand here. And then
What
again,
would the
here
dollar would mean here?
it's a hidden name. You can't write dollar as a name.
Mm-hmm.
So so it becomes a variable name that syntactic sugar wise, I'm making up a variable. Maybe dollar you can write, I think. So it becomes whatever ampersand. I don't care. Anything that I can write a string in the parser and emit as a string to all my internal things which do stuff with fields and structs and lookups and whatever that you can't write. So it's a private hidden internal, like I'd say dot. I often use leading space, which comes across very poorly in a text document for people to read later. But instead of percent, it might just be a leading space. You can't write that because, of course, I'll
Yeah,
strip
I'd
white
kind
space.
of rather give up the right to put dollar signs as the first variable character than the leading space that makes things hard to read as you're printing out debug lines.
Yeah. When it comes to debug lines, leading space is a kind of a bitch to debug. You're correct. So I'll pick some other character. I have done like dots, leading dots as well. Those get stripped and syntactically meaningful, so they get stripped off. But they print okay in a debug print. Fine. So something happens here. Somewhere along the way, I've said the first guy says ampersand, so the second guy takes a hidden argument. That becomes the closure that gets passed when you invoke those functions. And then when you say this guy runs, when he sees this function, which has this self-stack closure, he's going to make a closure object, which is going to capture. So the act of executing this code, and this code is executed, is not I give you a constant, which is the function pointer constant, as I give you a copy of the stack pointer and a copy of the function and a fat function pointer. And the fat function pointer is whatever it is, however that is implemented. In any language where I could control the code generation, I'll just return two registers. In any language where I don't, I'll have to actually allocate it as well.
Not sure what language I was writing in, but leading dot would give this super confusing message where it was like, float is not callable as a function
Ooh, he was trying to do a
because
float parse.
so the dot it interpreted as 0.0, but
Yeah.
without the unnecessary
Well,
zero at the beginning or the
right. Or
end.
0.5. Could be 0.5.
And that being just adjacent with the thing that was next to it,
Yeah.
which got wrapped in parentheses automatically and was a single argument call because adjacency was single
Oh, because
argument
of
call.
adjacency rules. Oh, bitch. Oh, that's terrible. Yeah, yeah, yeah.
It's got to have been
That's,
Ruby.
that's
I don't remember anyone else who did adjacency as a call.
AA's doing that. And of course, the obvious thing is you just pass a parameter on. You just wrap, you just wrap a tuple around it. There's adjacency as a call. I look up fun as a local variable. It's a function pointer. Yay! It takes exactly one argument, only ever, always.
So
I
if
look
I
at
put
the
a
next thing. Oh, it's a
space,
tuple. The tuple has some args in it. Oh, function takes a tuple. There you go. Now, what does function do internally? Function has some syntax sugar that says, oh, you wrote function as some things that had arg0, arg1, arg2, but, you know, internally I only ever take tuples, so I'm just going to explode the tuple as arg1, arg2, arg3. So yeah, totally this is a J. Let me move line here. This is
but if I put dot where you had fun, is it going to tell me float is not callable?
there's probably an error message of some kind, and the error message is always a bitch. So what was your syntax choice here? Dot.
I was going to say if you have a dot and
Yeah.
then arg0,
Yeah,
that
yeah.
it will try to call dot with arg0 and it will
I
interpret
think
dot
I
as a
will
float.
say this is not a float because it's not followed by a digit. So not a float. Must be a field lookup. Oh, it has nothing on the left-hand side.
Okay, so you're requiring floats to either have a digit before or after the dot.
Yeah, yeah. And I think I did what I'm really doing is I'm grabbing Java's float parser, which
Yeah.
makes this.
And I think that's why, because names are unallowed to start with a digit for this reason.
There's another thing to remember too. I think Java allows you to do like one dot as a floating point value
Yeah,
instead
yeah,
of having to say 1.0.
yeah.
And the reason that they get away with that is because you can't one dot anything else because one's not dereferenceable. So, for
Ah,
example, one dot toString is illegal. So,
actually in
But if I
AA,
put the one in parentheses, then I can
totally
do
do
one
that.
dot two string.
not in Java, but in some theoretical other language, I'm sure you could.
Yeah, AA will do this because floats take arguments, but arg0 is not a function argument, but not an operator, not an operator. I do adjacency calls with operators, but arg0 is not an operator, so won't happen here either.
So yeah, as much as I like starting with dot, just because that feels very Unixy to say, oh, this thing started with a dot, it's the hidden thing.
Oh, I see.
Maybe
Uh,
$sign is actually better.
but this is just like I need a debug. I need a name mangle that you can't write that's obvious when you print as a debug. There are many
Yeah, something
choices.
that's illegal syntactically
Right.
and legal for code production.
Yeah, visually obvious and debuggers is another key one. You have to be visually obvious when you're debugging, and you have to be illegal syntactically and legal to pass through the code generation pipeline. Yes.
Yes, and easier to deal with than C++ name mangling, from
Ah,
C front.
yes. Yes.
But I still think it's better to ban a set of characters as the beginning of variable names rather than say it's got to be this set of ASCII characters because you want to make sure that people can put in Chinese characters or Greek letters or the snowman emoji or whatever they feel like is important for their variable names to be.
Keep talking. Keep digging your hole. No, I'm there in that sense. I'm asking the Java is first character. They have a lexical character, whatever, is first legal first Java character or something.
I will
And
say you get some great bugs when you work in security.
yeah,
There
people.
was a Jira bug that came from the fact that two different versions of Jira were based on two different versions of Java, which had different versions of Unicode. And it turns out that the Mongolian vowel separator switched whether it was an alphabetic character or a spacing character between two versions of Unicode. So you could pass certain strings that would get interpreted differently based on whether it was one token or two tokens, based
Uh-huh.
on which version of Unicode.
See, this
The
this this all goes to never mind. The world was a lot easier when it was, ASCII or EBCDIC. Fine.
when there's exactly 256 bytes and you're done.
Yes,
What you're
exactly.
what you're saying is the world was a lot easier when no one outside of France, Germany, UK, and the US used computers.
Yeah, absolutely.
Not
I'll
sure
grant
what.
France and Germany some umlauts and whatever little backticks or something. There's 128 more past the ASCII set.
There's what, like 21
Unicode made
million
a lot of this
Unicode
shit a
code
bitch,
points?
that's for sure. Ah, fine. All right. I'm not really saying no to snowman emojis. I'm really saying, damn, that's a lot of work. I don't want to deal. Fuck.
Really
Ah.
a lot of work because it's not really any more than it's not work for you. It's work for the standard library author, whoever has to do the um, Unicode.
Well, there is
But
a
it's only done once. It's like the thing you said about the Java helper that you use. It's written once and then you use it.
Yeah, but there's some things that are very hard to sweep under the rug. So like Rust has a distinction between OS strings and strings
ah.
because the Windows NT file system is UTF-16, but they don't actually enforce the rules of the like low code point, high code point combination characters. So you can give like just a low half or a high half or a combination that's like two lows and a
So
high. And
I have personally experienced this nightmare. Yes.
and it's like, okay, you want to sweep that under the rug and say, okay, you need to use a special call to open a file whose file name is not representable as Unicode. But that managed to bleed into all kinds of Rust code that people are dealing with. That those people are
Yeah.
never going to want to save or open a file whose file name is invalid Unicode, but they still have to deal with this concept of an OS string.
So Java has the same issue in that it is not Unicode, it's UTF-16, which is different. So it has almost all the same flaws. And that's because at the time in the mid 90s, Unicode was 16-bit. And only later did they add um, the extension section, the whatever million extension code points with the two byte of values, and then only later did they expand it to the only later did they add the UTF-8, which is what everyone does now. So the old UTF-16 is basically forbidden in almost every place,
Right.
except
So
the
my
only problem
question
is
is,
is
how
that
do
it's
you, as a library writer, make it so that it is possible for people to interact with those things when they need to, but that not everyone has to deal with it all the time?
Make
frankly,
people
if you
write their
have to do
own
that, then you
implementation.
then you add an API that lets them pass a byte array that's opaque. Like, you know, there's
Yeah.
there's there's no way you want to be supporting a character string that's illegal Unicode just to support the NT file system. I mean, that's crazy. You know what I'm
We all
saying? Like
depressed now?
make your library correct and don't purposely make it incorrect just because NT did something crazy, 50 years ago.
It probably wasn't so crazy 50 years ago either. It just happens that that's the age, and Microsoft never backwards incompatible themselves.
Right, but even then they could have done the validation. That's the point. They didn't validate the input. So
I
they're
claim that was still a reasonable expectation when you're not ever going to see any, or you're seeing such a tiny amount of them at any point in time. And then later you would add validation, except somebody said, no, Hiram's law, they'll see it and get rejected. We shouldn't validate. And we know you should have validated back then, but I mean, Java started out with like a bad validator, no validator, will validate. Oh, we put one in. Oh, it was busted. Oh, people found holes in it. We got busted again. Third time around, we got a correct validator, but they kept changing the validator till they got it right. And I claim that NT could have done the same, and they didn't. And then water under the bridge, fine done.
Right. And the only use case I've ever seen for that particular kind of file name structure was that there were certain botnets that were naming all of their executables that because Norton skipped it rather than opening it when it was listing directories. So it never got scanned.
So I knew it was going to be a security hole, but it was specifically skipping Norton.
Eventually, Norton fixed it and
I'm
started
about to
using
say,
the byte array
presumably Norton
versions
fixed
of
it.
file system access
Well,
instead of the
let's just be
UTF-8
clear.
ones.
The fact that they had Norton installed is probably the biggest security hole.
Exactly, exactly. That was running through my head too. All right,
I
fine.
suspect in total antivirus has removed more viruses than it has introduced security vulnerabilities.
Yes, but not Norton.
All right, let's
Wait,
stop. Let's stop bashing public companies, well-funded public companies. And who knows where they're at now, but I'm not going to install them, but yes. Let's
Okay.
see if we can bring this back around to either coffee or compilers.
Yeah, something else.
Uh-huh.
Yeah, I think I have been convinced that you should copy immutably by default and make you do some kind of boxing
Now
thing.
I have to go fix my evaluator to do something sensible and make sure the IR looks sensible and all kind of things.
Particularly if you can make the boxing cheap.
If it's explicitly boxed by naming it, that's probably relatively cheap. Um,
I was kind of wondering if you could do something similar for return values to be like if this thing can escape the function.
that's not a return value. That's an escape analysis.
Hmm.
I mean, it's a return value in a sense, but return says, here is an arbitrarily complicated expression. Did something escape out of it?
Yeah.
Well, what's the type of the thing I'm returning? Up to the limits
So
of my type analysis, which will be conservative, presumably, I'll say you escaped or you didn't. And if I thought you escaped, you say, put in 200 functions in a big array. They all have all kind of references to all kind of other variables all floating around. The return says, pick one at random out of this 200 choices. That's what I'm returning. Did you escape? Every one of the 200 escaped. Okay. Every one of them
And you
has
don't
to
want to
be.
make me put an ampersand before all 200 of those because there may be escapes.
Well, that's the point. That's what I'm saying. If you intend to capture by one or the other, we have to go do something about that.
Because there's
The-
something nice about having syntax where I can just look at a variable name and know that it maybe escapes or that it never escapes.
Yeah, and I think the ampersand is nice in that it says I escaped, and the non-ampersand says I captured by value immediately, and so it didn't escape in that way. It's just like a Java effectively final without the syntax.
so
Same as
if
the
it's
default for no volatile from
Yeah, I
X.
don't have a good word for that. It's kind of the opposite of escaping. It's this variable broke in.
yeah, Aaron, I'd still argue against that just because, like, w- why do you want the reader and or writer to be doing the work of the optimizer? Like, that's just like I can understand it, maybe some of that in AA, but for typical language where you're building an
Hey, hey,
application.
hey.
No, that's not an insult. It's like you have specific goals with AA
Yeah,
and
but
you're
one of them is
consistently.
to read easy and then know that you get performance or that, there's a separate way to say performance. You're doing something that's performance expensive here.
No,
Are
but
you sure?
Yes,
when
you
you
want to be
say
able to
read,
reason about performance on a printed page.
Yeah.
but to be fair, when you say read easy, you mean for Cliff to read easy.
Absolutely.
Yes. I just want to be clear. That's not bad. It's just
Yeah, right. I don't know what other people find easy to read. I write stuff that looks easy to me, and they come along and say, "Oh my God, I don't understand." And then I talk to them for an hour, and they're like, "Oh, this is actually really obvious." And I'm like, "Okay, why wasn't it obvious from before? And it's obvious now. I don't understand." Fine.
well, what you're
Here's the question for you. In this here while loop, was there anything obvious or non-obvious about how to read it? I thought we were pretty good. But when you come up here to the generator and I start returning, oops, this guy, or start returning things, I mean, I'm heading into obfuscated sea land here. I got as short as possible. You put your gray arrows back, that might help. Is that easy to read? I claim you're doing a funny thing. As soon as you're doing a funny thing, it's never easy to read. You're making a generator of counters. You're generating a counter that you have, make a new counter. And except you're doing with stack frames. And I claim the easier solution here was to say Java, class, new counter, int counter, increment, and get. That would have been easier to read. Now, do I want to write all that out? Is that tons and tons of shit to write. Yeah, there's a lot of boilerplate there. Is there an easier way? Yes, it has less boilerplate. Is the less boilerplate easy to read? You tell me. This is where I don't understand. I subtracted much boilerplate. I could subtract even more. The AA, I just went and said, "Ah, fuck it, get rid of all the boilerplate." Now, is it easy to read? Hmm.
It may be still useful to have some explicit notion of mutability for reasoning about in the context of multi-threading.
I haven't tackled the multi-threading, and I understand the reasoning about mutability. So the AA choice was if you don't ask for mutable, it's immutable, deeply immutable by default. And that's an explicit choice based on conversations we've had at Coffee Club over the last, 6 months, a year. By default, you're deeply immutable. You have to ask for mutability. Specifically, you, Matt, hammered on this point a lot. So okay, we'll give this one a go. See where do I have a blank line here?
But I'm not sure that Matt represents the typical application
I
developer.
don't either, but I'm willing to give it a
Yeah.
go here.
The thing I think about with readability is it's both a function of what's written on the page and what's in the developer's head.
Uh-huh.
I had this one physics professor who I would go to the lectures and I would take notes and I didn't understand anything he said. And then I would get back to my dorm room and I would read the notes, and it would all make sense when I was reading the notes
Really?
because he had no concept of what order in which to give you concepts.
Oh.
So if you listen to the entire lecture, it would make no sense. And then if you listen to the entire lecture a second time, all the stuff he was getting you at the beginning made sense in the context of the stuff he was going to give you at the end.
Implicit forward references.
Um, and that was just true of every lecture that this guy ever gave. And I feel like to some extent that's true with code. I've worked in Go code bases and I've worked in Clojure code bases. And in my experience, Go is much easier to take a tiny snippet of a system you don't understand and know what that piece of code does because it's very structured. And the Clojure Lisp stuff, you would go and it's like, okay, here's 87 names of functions that I don't know, and I have to go read those things and come to understand what those do. And my amount of effort that it took to get from I have no idea what's going on to I have any idea at all what's going on was huge. But then from I have any idea what's going on to, oh, this is actually a really nice, tight language and set of controls, and I can write things and be very productive. And it just took a lot of time to get to the point where I could be productive at all. But then once I was productive, I was a lot more productive.
That's a pretty good segue to Simon.
Simon, you
You
got
got-
something to say?
In what sense?
You got Simon on, and you were waiting to hear something from him, weren't you?
He is not currently volunteering anything.
Dave, Simon, on the stuff you were talking about?
Will you come again?
Did you have any updates on what you were talking about on the chat earlier?
On
Discord?
Discord. We were just
I mean,
Discord. We were talking about loading fields as functions or fields as method instances and invoking them.
yeah.
And I opened
mean,
that.
it's a bit different from the things Cliff showed. In the end, let me paste.
You want to
something
share?
into the Google. No, I just paste it into the Google.
You're gonna go to Docs
Just-
or
Just share the Google Docs. I'll paste
Okay.
something in there.
maybe make a new code block. Yeah.
Oh, yeah.
Yeah.
So where am I? So basically my motivation is more along the lines of let's say I have a class like this and it has a few fields and a few methods, and from the outside I can use it like this. So just create a person and I can access the name and the first name and the
So
last name.
we got properties,
And-
functions that don't need
and
parameter
I-
function.
Sorry?
Functions of no arguments that don't need parens to be invoked.
Exactly. And ideally, you could imagine that the class person is defined in some third-party library, and that library adjusts the way it is implemented. And the desire is that your code here, the calling code or the code using person, does not break and does not need to be changed just because the library has changed which parts of its members are fields and which parts of its members are functions. And to do that, it's of course let's say necessary that you're not only able to define functions with parentheses and then be forced to call functions with parentheses, but that you're also allowed to define them without parentheses, call them without parentheses, so that from the calling side, it's not visible to the user how these
Your
things are
goal is to
implemented.
allow people to just have a mutable field that gets replaced with a more complex getter and setter without the API changing?
Exactly.
I go both ways on that one. It's like,
Would you have to recompile the call sites though?
surely you must.
No, sorry?
Go ahead.
No, I mean the idea is where is it? Pasted it somewhere. It's like the idea is that this representation can somebody give me Unicode plus thanks is not only looking like this in the source code, but that the way you're representing it in the AST and in the bytecode or whatever IR you're using is that you're not saying, okay, like if I have like this .foo fragment in my code, I encode this as field access, the symbol or the name or whatever. And if I have this fragment in my code, I represent this as an invoke method with like a specific name and its arguments. But you slightly adjust the representation both in the AST and in the IR such that
Somebody who emits code has to be recompiled here.
sorry?
Somebody who emits code. So AST
Yeah.
is not emitting code. It's a step towards it, but it's not emitting code. IR is not code yet. When you
Yeah.
get down to code, like if you get to the linker step, if you're linking a field reference versus a function call, you're broken. You need to be recompiled.
You know, but during linking you figure out
Hmm.
so basically that's the
That's
idea
fair.
basically.
So you have an explicit linking step that
Yeah, I mean
determines the
it's
difference
not
between a
more
memory load and a call.
it's
I-
not more
well,
explicit.
okay.
It's not more explicit than any other kind of
I
linking
claim
steps.
you lose much of your performance immediately because you fail to inline the trivially inlineable function. If
I
you
mean,
fail to do
that's
code
like
generation here,
figuring out what it is, you only do it once during linking, and after that you can optimize all the way you want.
well, no, the usual rule is once you're linking, there ain't no optimization after that. You're
But
dead.
Cliff, like you're misusing some of the terms though, because you could
Uh,
imagine that linking is when
right.
hotspot
I
kicks
totally
in.
know. So this implies that there's a JIT, which is what I was saying. Somebody does code generation after, in this case, after linking, and that code generator is going to have to recompile. But now you're implying a JIT, which is fine, but come out and say it.
Right. Well,
I mean,
I
yeah,
think
it's
when he says
it's a
IR and bytecode, I hear that.
Okay, I didn't hear JIT. It does make a
yeah,
difference because there are plenty of
yeah,
folks who won't touch you because you have a JIT. And there,
yeah. I don't care.
I mean, I'll
So
it's just easy, but I get
yeah, so
hammered all the time. Oh, you're jitting, you're slow, we're not gonna touch you. And I'm like, no, fuck, I'll beat you every time with a JIT, but you got it hard in
yeah,
your head that jitting is slow. It's not. Fine.
yeah.
Well,
No,
it
Oh,
was
it's the
back in
every time that gets you.
1985.
I talk to high-speed people and they're like, no, the JIT only wins 99% of the time. That
Exactly.
one time when we're having a flash crash and my compiler goes, oh, I haven't seen a flash crash in 17 years. I don't go compile that code.
It's too late. The flash is done. You're dead. Yes.
So
Yes, I think we saw
generally
earlier.
speaking, though, the people who believe that are not actually doing any real work because, I can tell you for a fact that the number one high-speed trading system in the world, which was eating everyone's lunch for a decade, was built in Java. No C, none of that bullshit. They couldn't do it in C. They couldn't do it in C++. They did it in Java. And you know exactly which company I'm talking about. So I'm not
Yeah,
going to name
but
any
they
names.
cheated. They ran the test suite on startup so that literally every code path got compiled.
But that's not cheating. That's just running a warm up.
So, but they were actually deploying algorithms in the middle of the day as bytecode. So again, like all the things that people believe are bullshit because the people actually doing the work were doing it in Java and not worrying about the JIT.
Just saying, though, still get a lot of pushback.
Yeah,
So,
that's because ignorance is far harder to
y-
kill than
yes, just
most
saying if you're
things.
headed for new language, broadest possible audience, but maybe you're not. Maybe the answer is you're headed for illuminated programmers or something,
Look,
enlightened.
for every one person that gets to the point with C++ that they're able to actually do things that someone else could use, there are at least 100,000 programmers getting up to speed with JavaScript to that same level. You can't go chasing
Okay, fine,
the people worshiping legacy crap. Like
fine.
that's not worth it. There's no payback.
Okay, fine. That may be true too.
See, I'm caught between my desire to not worship legacy crap and my desire to worship stability and not having new language releases break my code.
So JavaScript, particularly in the UI layer, is notorious for code rot, and we've talked about that before, where basically every change, like like as soon as you have working code, the clock is ticking, and within days or weeks, it will no longer be working code, and it's just crazy. Like I don't know how we got here,
Or
but
it's still
Well,
working, but
you
it's
pick
not
the two
good enough
paths.
anymore.
You either tread water in place to keep up, or you refuse all future bug fixes.
Now we are much louder.
I've done it both directions.
yeah, but even with JavaScript, even not picking up the new changes, you're still going to break, and that's the crazy bit.
You pick up the old bugs, and
No,
then
no,
learn to live with the old bugs.
like because the world changes around you when you're JavaScript on the UI, the world is changing around you and stuff just breaks without you adopting any new library updates. It's called bit rot, right?
No,
It's
no,
just the
I know what you're
fact.
talking about. And I did a JavaScript UI thing. I didn't run it more than a few years. It didn't bit rot because I went the route of stability and
Right,
refused bug fixes.
right. Well, you
Except,
also specifically are still on Windows 10. So like you're your own ecosystem. You're your own biome.
when I did the JavaScript UI, I was not my own biome. That was being picked up by people whose phones were going to use this app to go do their factory floor management thing with the, IoT things.
There's also questions of what's stable and what's not. So if you write a React app, it's going to rot very quickly. But if you go
But
back to like addictinggames.com and play the jQuery JavaScript apps that were written in the like 2004, the jQuery apps still run fine.
I was using
React
React.
is definitely the worst. Like any code you write in React is guaranteed to not work within 30 days. It's
I'm
shocking.
telling you, this is not true. I did React. This was a React app, MobX, React, FlowScript, and something else. And the answer was I locked it down for 6 months at a time. Then I spent 2 months churning to collect up the bugs and get to the next stable. And then I spent 6 months stable by refusing updates. And you could get there. You could get it stable, but you had to live with the bugs. And then I had plenty of stupid hacks that were living with stupid bugs because I didn't want to touch the update. And then at some point I said, well, now I absolutely got to have the whatever thing I had to have. And so I took the update and then I spent so many months churning the bugs until it's stable. And then I locked it down again.
So back to Simon, I'd say on your IR, just explicitly have a, property get, and if you have mutation property set, and then that becomes the representation of field versus method. Like call it what it is. It's a property.
But I don't know what it is, right?
Yeah, I don't know what a property is either.
It's
This is
like
a,
it's
this is a
a
Exactly.
different special
I'm not
ecosystem
I'm
term.
like I'm
The
not trying to make the determination in my bytecode because I'm referring potentially to a third-party library.
right,
And
exactly.
what's in there, I don't know.
Right.
It
But
purposely
it's
erases what is it a function or is it a value or
but it's a representation of something that you don't know. That's the point. That's what a property is. It says it may end up being a method call, it may end up being a field load, or who knows what else. That'll be determined at the initial lick.
I claim that's not a fair description. For what you have for properties, it's blatantly a function call for readers and writers, and you're hoping the implementation will inline it down to something more efficient. But the semantics are equivalent to a function call in
That's
both cases.
exactly what I would expect someone who writes a JIT to say. That's a
That's nice,
perfectly
but this
valid implementation answer.
if I
No,
was
I
writing ecstasy in OCaml, I was writing ecstasy in Lisp, I was writing ecstasy in fucking assembler or anything, the semantics of what you call property are pretty blatantly a function call.
Well, it's two function calls, one for set, one for get.
Yeah, it's two different function calls. That's absolutely.
But
Yes.
at that point, it's more about the name you pick for select. I mean,
Well,
if you want to call it get property, fine.
you don't have to call get and set when you use it. You use it like you just did. You just put the name
Yeah.
down or a name with an assignment for the set version. And the syntax to write it is very easy. And the obvious for me, the obvious eyeball performance is, oh, this is a field load or a field write. It's one clock and commons up and has optimized and loop invariant, blah, blah, blah. It's cheap. Whereas if it's a function call under the hood, maybe it computes Fermat's last theorem the hard way and takes forever. I can't tell anymore by looking at the code what the performance is. So this for me, this kind of a style of thing fails the I can judge how the performance goes by looking at the code. I no longer can. I have to go look at the implementation of class person under first and last name to figure out what the performance is. And
I mean,
that's my
but you
take
have
on performance
but you
analysis.
have to do this also before. I mean, every time you'd update the library person is located in, you'd have to look how is
If I'm
this
updating a library, I am buying into the I have to go reevaluate all my performance. That's correct.
yeah, so it's basically not the invocation step that's in the bind here, in my opinion.
All right.
Right?
I normally would say I'm going to glance at this code, only see field assignments, field read writes. Okay, I have a good
Yeah,
clue.
but I'm not making that claim because like what the code does is defined by the implementation or not by my
Yeah.
invocation of it.
Yeah.
Okay. I'm
I mean,
saying
it reminds
because
me
of
a lot of
that, I can't look at this code and tell you what the performance is. I have to look at a
so
broader scope.
right.
Ruby and Ruby on Rails has a bunch of these things that look like objects, but a field access could actually be a function call, and that function call could actually be an ORM object that is doing discretes.
Right.
And the way Jack always used to talk about it was we started Twitter on Ruby on Rails and didn't know what it was, and we're moving fast and wanted to change a lot of things, and we didn't have these enormous shotgun changes. We often could make a change in one spot because of the flexibility that Ruby
Yeah.
gave them.
Okay.
And they've made the argument that there's no way Twitter would have survived its first 3 years if they didn't have all of that flexibility that they had with Ruby. And then as it scaled from we've got 10,000 users to we've got 10 million users, they had to pull out the entire monorail and rewrite it as Java services and got the performance and reliability out of it and made
All
the
right.
fail whale go away.
No,
And I think there both really is a place for this We would like to be able to make small changes in small places and not have shotgun surgery over the entire code base.
No, that's a valid argument.
But when you want to get real performance, then you start needing to pin things down. And that the company wouldn't have survived its first years in a language
But to
that
be
was
fair,
not
what
like Ruby, and
Simon
wouldn't have survived its late years in a language that was like Ruby.
what Simon's describing, though, where he has an IR representation of what you're calling Ruby, and then that IR representation is what Cliff's JIT would pick up and turn into a function call, which would then inline and become a field load. Like you could still, by demarcating those transitions very clearly, you can still get the performance that you get, at least with, say, Java, which is, the 99% good enough. You can still get that performance with the functionality that you're associating with Ruby.
Right. If this lets you go smoothly from the we need to move really fast to we need to really pin down performance, that's huge.
I'm making a different statement, which is the performance model has been hidden. If I don't care about performance because I'm working with 10,000 people, then I don't care that the performance model is hidden.
No, it's not that you don't care about performance. It's that you're willing to accept that a property access may glue two strings together versus a field load. And that you still care about performance.
If I don't care about performance, I don't care about performance.
But if it makes a side effect, how do you account for that? If the dot foo is a field and you don't that all of this is evaluated, but it's
right. The Cameron's properties include side effects on getters. Getters can bump into
could do, sure. They're just functions, sure.
Yeah. Which you just said it, they're just functions. There's a nice syntax for accessing the getter versus the setter. No denying the nice syntax. But they're just functions, which include every possible side effect, which does also make code hard to understand if you take advantage of that side effect thing. It worked this pass, it didn't work that pass.
So it's easy to understand for the person building the application. It's hard to understand for the Cliff who's looking at the code and saying, is this a field load?
No, I claim it's not easy.
So what is bad about it is precisely what is good about it. So
yeah, exactly. So here's an example. I'm running this code. It has this fancy print function because it's complicated. I stop in the debugger. The print function runs because the printer's doing toString on every argument. It's super nice that the print function runs. If my print function, however, has any side effect, then I randomly get it or not, according to whether or not I stop in the debugger at a particular stack frame or not. And I've had plenty of bugs where the large complicated structure internally has self-healing and self-optimizing properties. It references do union find roll-up steps and the like. Stopping the debugger did a union find roll-up step during the print. It hid the bug. You can't do a normal accessor in a toString if you're going to use it in the debugger. And Java's toString will only use toString. The debugger will only do toString. So toString, for all the implementation stuff I do, is very carefully functional. And also there's a whole nother layer of things that has to be used to get performance out because the union find algorithm sucks in performance unless you do the union find algorithm. So it does the find, which has side effects. And I have these two parallel implementations of things. One which I can call from toString, which won't do caching, for instance, which will give you asymptotically terrible performance because you failed to cache, or things that the program's using normally, which cache, but I need to know, did I hit or miss in that cache? And that happens to me like all the time.
Hey,
so all these
Cliff?
things, sorry, I'm ranting, I'm done.
No. That was very interesting, but I didn't understand it. So what was this about the debugger and the toString?
Yeah, right. So
because the debugger calls you toString behind the scenes.
Yes.
I mean, I guess that's then more the question whether the toString function should have
I need a
parentheses
function
or not.
that the debugger will call by default that will do some interpretation of my very complicated data structures. So that's a wonderful thing for the debugger to do. I love to have it call an interpretation that I can then read and eyeball one line in the debugger and know what the hell's going on. That's great.
Okay.
Now, it's called toString.
toString should be field access so that your have a guaranteed performance model.
Yeah, I need to toString to
No,
do
he's saying the
interpretation.
opposite. Simon,
Yeah.
stop. You're hurting. No. Cliff is saying he'll accept any cost on toString because fuck it, as long as it doesn't mess up his data structure.
Right.
And then for his
Then
performance,
don't write it
he's
that way,
messing.
right?
No, for performance, he's having to mess up his data structure on purpose because
the algorithm.
mutability gives him 100,000 times the throughput.
Yeah, yes, it's asymptotic, so exponentially more throughput.
I have to exaggerate to make my point
Yeah.
Yeah,
faster.
okay. To just be clear, I have many cyclic data structures where if you don't do some form of caching, you will simply loop forever and it will crash. So it's not even that it's performance, it's a hard, dead in the water bug if you don't do the algorithm the fancy way.
So what you're saying is that big O of infinity is bad?
Big O of infinity is bad. Yes, that's correct.
Okay.
So you want your toString to cache the output of toString for performance?
I need
Is
to
that what
have
you're
a
saying?
version of
No.
toString which doesn't change the underlying data structure. Also, it doesn't loop forever. Also, it does visit things, so it can do fancy interpretation.
I mean, check in your toString whether you're in a breakpoint, problem fixed.
Every time I stop at a breakpoint in any debugger, well, IntelliJ, but any debugger of any worth, he takes the current things and does some kind of interpretation call on it.
No, Simon's kind of asking the right question, but the answer is no, you don't do that, and you basically can't do that. There's no way to say, am I being called from the debugger? I wish. That would have saved my ass.
Via chain I or something.
Is the problem that people can make a side effect in toString, and so you don't want that in the debugger? Is that what you're saying?
Bill, what he's saying is he cannot implement toString without a side effect. It is impossible. It will never finish.
Right.
Never. Not in a trillion, quadrillion years. It will never finish because it's an infinite loop without mutability because of what the data structure is.
I'm writing a compiler.
So Bill, ask yourself this question. Garbage collection.
Yeah.
Garbage collection has to mark. It has to change bits. It marks sometimes when it's visiting, sometimes, whatever.
Yeah.
Like that is a mutation.
Yes.
Like, so if you're debugging garbage collection in the debugger and one of the variables is some data structure and it hits that variable, it's now going to start marking things and you're debugging marking. So you're fucked. Right. Like this is the answer.
When you stopped and looked, oh, it's already marked. Great. No
Okay.
bug.
This is a fun conversation. Unfortunately, I got to drop, but Happy New Year, everybody.
Happy New Year.
So I don't know what the moral of that story is, other than I end up with dual implementations. toString has a version which secretly maintains a separate cache so that it doesn't crash me.
The approach that I have in my language is that toString requires a trait bound called stringable or something that pipes explicitly have to implement for toString to be called. And there's a separate function somewhere hidden in lang.runtime.debug called debug string or something that can just be called with arbitrary objects, deals with all the aborts on recursion and loops and does some pretty printing and so on. But it only works in debug builds. So if you call the function in a non-debug build, it will always just return an empty string and be done.
Just saying here, my fix. Emacs is not polite with Zoom.
That's my approach to tackling at least parts of the issue.
So as an example then, if I have some kind of infinite data structure, why would my toString run forever? That's kind of like useless.
Okay, I'll show you.
Yeah.
So are you? Can you see code? Are you on a?
Yes, I am outside digging, but I actually put my laptop over here. I can look at it. Yeah.
So I have a cyclic data structure, and I want to see, this is a typing structure. It has integers and floats and pointers to structs, which have fields, which have any scalar value, which could be pointed to a struct. It could be itself, because you might be pointed to struct, pointed to struct, pointed to struct ad infinitum. It's actually pointing to struct to just cyclic directly. So if you call recursively, so I call toString here. Now you'll notice I have final on this toString because I'm breaking the bug. But if I don't have final and I just called toString on a type mem pointer here, he would come down here and he would say, oh, print something about final or not, print a pointer to a star, go to that thing struct and call toString. Okay, what's in the struct? Well, the struct here, let's go find string struct. Struct here has a short version. The long version says, oh, I have some fields. For the fields, print. Here is type print. Okay, what's a type field? That's a field thing. Okay, it's an array of fields right here. I'm calling field print. Oh, what's a field do? Well, a field just has a generic top level type. So if I've made a data structure, so the useful thing of the toString is it prints pointer to struct person who has a field Cliff, whose name or field name with Cliff and whose age is 63, whatever. But I can also have a struct that says, I have a pointer to myself. I can make a one entry cyclic struct straight up and okay, if I go toString on that, he says, I have a pointer to a struct with a field whose X is a pointer to a struct, which is a field to X.
That's an infinite loop.
And it runs forever. And it runs me out of memory and crashes.
Okay.
So I don't want to do that.
No, you wouldn't want to do that.
Okay, so I can't call toString by doing the obvious recursive descent on my type structures. Now, my type structures are obviously self-referring and they're cyclic. They can be made cyclic. If you write a cyclic type, you get a cyclic data structure.
Yes.
And I want recursive descent, but I can't do it. So how do I fake getting recursive descent without killing myself? So somewhere in the bowels of the universe, toString flips over to a version that says I have an internal cache of a mutable thing that I'm going to use to know what's going on. Here, I'm going to start with the first cut, which is I'm going to not do endless string appends. So that's a string builder with SB, has a couple shortcuts. But I go to a print. Okay, somewhere in the world here, where's my print? Get fancy here. Oh, this one probably in fact fails on me because I didn't bother because I didn't need to. It's AA as the actual. I do that for. Let me go with the AA one. It's a simpler version of things.
Oops.
So toString. Here's this guy. Oh, string.dupes. And then string print. What does dupes means? Well, when I want to print a guy who is a cyclic structure, I want to print a name for the dude who's about to be the head of a cycle, print the thing recursively, but when I come back to the head of the cycle, I'm going to print the shortcut name I come up with.
Okay.
Where did this come from? He says, oh, I have a print environment. I have a visit field. It's a bit set. I have a bit set. I test and set. And I have overloaded copies of this. So if I go look at how many things I have here for stir dupes, all I'm saying is at this point, I've got a bunch of versions of stir dupes that do things. Come up with names like you're replicating a field or you're replicating something else. I'll give you a fancy name which says A1, A2, A3, or V1, V2, or something like that. Oops.
So it basically terminates.
It will definitely
terminate. Finite string. And
what I said was toString can't go recursively with recursive descent naively. He needs side effects. In this case, visit.test and set is a side effect.
Okay.
So with this version of toString, he only needs the effect of I have an extra side structure to maintain that has it's a cache of bits of visit. When I go to the union find structures, the normal accessor, I say, give me a thing that is a union find based variable. I normally do a find step because that's how union find works. But toString on union find means that toString did a find step. And if I have a bug where I have accessed something accidentally without the find step, the act of stopping in the debugger right around the point where I want to debug does the find step in the toString and hides them.
Okay.
So toString on things with find steps immediately go to another version of things where they have to have They have to have smarts about not doing it. So here toString says I'm calling this internal string, and you see it's a final toString, so I can't accidentally write a toString without this.
Mm-hmm.
Passes in a crap ton of variables. One of them, easy first cut one, says, "Oh, you didn't specify your default. Make a new visit set,
Right. Yep.
new dupe set." Right. So I'm saying side effects happen hidden.
Yeah.
And toString in particular is a bad one.
Yeah,
So
that all makes
you have
sense.
to have a version of toString which is smart about side effects and doesn't do it. Here down here, he asks the question, do I need a unification already or not? And if I do or I don't, I'm going to print you with this right arrow that says, here is a missing find call. And I'll give you the original variable and who we got
Mm-hmm.
forwarded to and the find step without actually doing the find step.
Yep.
But then I'll take the forwarded point and print him recursively. And you'll get, I forwarded you a couple times. It's union find. You never forward more than 5 or 6 times, or you're crazy. Something crazy happened. But he'll forward a couple times and then get you the actual variable. But he didn't call find because that would have busted me.
Right. I see.
Whereas up here, I say if I'm not in debug mode, I'm printing my final answers at the end of the world. I can be unified. I'll call find. That's okay because it's not part of the normal debug call. This is the print that came from the edge of the world, from the end of the world.
Okay, so let me just make. I think I got it, which is that to actually implement a toString that doesn't go forever, I actually would need to do some side effects. It could involve something that hides a bug.
Yes.
And that's what the problem is in the debugger. It's like if I just call toString, it's like I can't see the bug.
And here, this new, that gave me a new cache. And
Yeah.
I'm just relying on garbage collection to survive, to have a new cache available for the toString call.
Okay.
I mean, use toString only for debugging.
Oh, yes, I use it for debugging. I actually also
Yeah.
use it because I want to have my test cases just come out and say, at the end of the test case, what is the type of the result? Well, that's just a toString call. Boom, done.
Yeah, I'd say like toString should be close to constant time and only used for debugging. It's like a rule I use personally and also at work, and there's no issue with it. It's like if you have some fancy type and you want to have it printed for some kind of purpose, fine, but
Yeah.
don't call the method toString. Works.
Well, that's what I'm doing here. I see. Okay, fine. So AA, I got far enough along that I came up with 2 prints, the toString for the debugger only, and then a print call that was my, here's your final answer. And they just set a flag and they go into the same shared code, but they set a flag saying whether or not they can use the normal accessors like find or not, whether they should print the unified, who you unified to, or just do the find roll up, things like that. So yeah, I did that in AA. Okay. Here, I was hoping not to do that. I'm not using a UF algorithm here. Well, I'm actually using it in the register allocator. So there's a half of a register allocator. It's not up into simple. It'll be coming along. It definitely uses union find. There is a toString that has to be smart about the union find on it, so on and so forth.
Hey, that was good. Thanks. But I had one question that if you have, with this few minutes before you.
We're here for this.
Usually, which is about your Lattice list 2 weeks ago,
Yeah.
I kind of was trying, well, let me tell you my understanding of the optimization lattices is that they are mirror images of each other, just so that you can know you terminate when you do this analysis.
No.
You always go down.
No, they're a mirror image, so I can not lose, so I maintain the Church-Rosser property as opposed to, so they terminate because it's a bounded lattice, it's a ranked bounded. Bounded just means it's not infinite. Ranked means it's got to count. It's a known small number. So it's a bounded lattice of depth 3, 4, 5. And I'm limited to 5 trips on any given node. So five times a node times the count of nodes is the limit, and then you're done.
Yeah.
I could probably pull those lattices up pretty quick here, or a sample lattice here. Docs lattice. This one. How about this one?
Oh.
Yeah, here we go. I'll share this. So
Where is
here's the
okay,
chapter
yes. Yeah, this
17,
one, I think.
18 lattice. You count 1 for the top, 2 for float, 3 for total float 32, 4, 5, 6, 7. So that path has
Yes.
7 drops.
Yes.
The other ranges are all 3 basically. Well, 1, 2, 3, 4, 5, 5 basically. Except the integer ranges have to have a hidden extra thing that's not in this picture for a widening effect, or they could have an infinite drop or size of your integer fields drops. So the
Okay.
ranges are missing in this diagram. But this is the lattice. The
So,
symmetry is so I get a Church-Rosser property which says I can visit the work list in any order. Like if I'm at a node and I go visit the work list says visit this node and update its type
yeah,
just feeds into this node, and I end up
right.
down here whatever this node gets. And the work list is start here and visit this node and change his type, then visit this one, and you get 2 sides of a square, and I get to some other place in the world via 2 different paths. I always end up in the same spot, even when I'm coming from loop back edges at tops of the world. So
Okay.
there's the symmetry gives me an easy guarantee that
Okay, so what I can tell you what I mean, what it looked like to me from the, like, let's say from the top node, the black circle with
yeah,
to the middle,
yeah.
that looks like types, sets
This,
of values.
this is my
And
type
then
lattice.
going down, it's kind of going in the other direction back to, like, basically at the beginning of your analysis, you don't know anything about it, so you're at the top. At the end of your analysis, you may have figured out, it could be anything,
Yeah,
and so you're at the bottom. But that kind of means the same thing. It means anything. But one is anything, but I don't, because I don't know anything about it, and the bottom is anything because I actually know that it could be
right.
anything.
So
Okay.
to save my brains on jargon, I don't use anything for both sides. This I
Yeah.
typically call all. The bottom one I'll call all.
Yeah.
This is an error. If you got here, you have a conflux of things like I mixed floats and function pointers together.
Right.
Well, you can't
Right.
have floats and function pointers together in any sensible way. So that's just a bug.
Okay.
But this bottom int meant, yeah, I had to go compute that int at runtime. I know nothing about it at compile time.
Right. Correct. Yeah.
Where this one up here, this top int, that says, I know every possible thing about this int all at once, all simultaneously. It's over constrained. I know it's the constant 0. I know it's the constant 1. I know it's the constant 2, 3, 4, 10 billion, all constants,
Yes.
all at once. That's an impossible situation. So mathematically, it's a little weird. And I start throwing out choices as the code comes along and says, no, you're not 1, you're not 2, but maybe you come around a loop. It would be really nice. Hey, C author, really nice if you happen to match the back edge, which was bool. So falling into the loop, I can choose to be bool. So I'm going to choose to be bool. I match the back edge. I hit a fixed point and I'm done. Hey, it's capped at range of bool. Something like that's going on here.
What's the difference between the top int and the bottom int then?
This is choice of all possible constant values. Choice.
Right.
Compiler's choice.
Yes. Okay.
This is, you had to compute it at runtime. I have this stupid C program I pull up from time to time that shows the kind of thing that happens here. So main, whatever, int x, I'm not going to define it, while true or arg or whatever, I don't care, it goes on here. We're going to do something here. We're going to say, if x is true, then I'm going to set x to true. I'm going to run statement 1, which prints whatever.
Mm-hmm.
Else, I'm going to say, oh, x is 0.
Right.
2. Okay, this stupid program. Okay,
Yeah.
what's the semantic meaning of this program? Oh, it's got a UB in it. It's undefined. Well, okay. You throw this at any sort of classical conditional constant propagation.
Mm-hmm.
This value here is the top integer under the hood.
Mm-hmm. Oh, that's
But
interesting.
test
Yeah.
here wants to say top, delay my choice until I know what x is, don't execute.
Mm-hmm.
Because if it were to be 1, I would execute the first. And if it were to be 0, go to execute the second. So just delay. Then you run out of things to do. You hit a fixed point and you've delayed here and nothing runs.
Mm-hmm.
That's kind of a funny thing. But I could come through and say, oh, I'm going to read whatever stack frame value I get from x from the local C stack.
Mm-hmm.
Which I could just assume as a compiler because it's compiler's choice. The compiler can arrange that stack slot to be whatever.
Right, that's true.
he arranges for it to be 1 or some positive value, some non-zero
Sure.
value. Then X
Okay.
is set to 1 and statement
Yep.
1 runs. X is never 0. Statement 2 is never happening. It would
That's
be
right.
legal for the compiler to run only statement 1 and dead code eliminate statement 2.
Sure.
I'll repeat that same exercise where the compiler chooses 0.
Hmm.
You throw away statement 1 and only execute statement 2.
Right.
So at this point, I have this funny situation where compiler's choice, statement 1 only or statement 2 only. Is a compiler's choice.
Or neither. It could pick 3.
He could no. As soon as
Well,
you
it's
pick
if X. So.
you run statement 1, you set it to 1. It's always non-zero, and forever you're running 1 and never 2.
So compiler's choice is int colon top, and the int colon bottom is where it's actually I don't know what X is, and so it's passed in, and so I don't know if it's going to be 1 or 2 or whatever you had, 1 or 0. So
so as a programmer who's trying to figure out what this code does, my easy expectation is either it runs 1 only, or it runs 2 only, or the compiler says he's going to read from stack memory. It'll be something, whatever it is.
Yeah.
And he'll pick 1, and both 1 and 2 will appear in the code.
Right. Yeah. Okay. That's 3 choices. I guess maybe that's win by the 3rd choice. But anyway, so last question. If you
This is compiler's, the top guy is compiler's choice.
Okay, cool. So now let's go down one arrow, which is min greater than max is opposite min less than max.
Yeah.
So that's why I was wanting to know. It's not. I mean, that's symmetric. But you flipped it.
Yes.
So why?
Okay.
Why is that different?
Okay, stupidly and not stupid. Deep philosophy or stupid, take your pick. It's because that's how the math works. I have to do an implementation. There has to be code involved. The code I end up with wants to be symmetric and bounded ranked.
Right.
And I'm trying to say I want to handle ranges. Somewhere in the world, I want to say I can handle a bool range, or a uint32 versus an int32, or any other set of ranges. I've got an enum. I'm unrolling a depth for byte reversal algorithm networking code. I want to know the range is 0 to 3. I have these ranges I want to deal with. But I want the duality so I can get the property that says I can visit them in the work list algorithm in any order and I'll get the same answer.
Okay.
So now I need a dual. Now comes the question, what does the dual mean? So the first easy answer here is it doesn't matter what it means. It's there to make the math work.
Right. Well, okay.
Seriously.
I like to have meaning, but yeah, okay.
Okay, so now can I add an intuitive meaning?
Yes, what is
yes,
the answer?
It turns out I can. And the answer here is, this is compiler's choice of 0 or 1. All other things are denied. You can't be a 99, can't be a minus 17, but you could be 0 or 1 and the compiler can choose.
Okay.
Because the compiler chooses any number up here. He just has fewer choices.
Yeah, right. It's compiler choice. Yeah, it's fewer choices.
He has fewer choices here. But he has choices.
Yeah.
And that's it. That's the intuition that I've thrown on it. But as far as I'm concerned,
okay, but that's all right. I'll think about that one.
Okay, the
one.
intuition
Why
might
is one?
Then I tend to think of it as may versus must. The top half is the compiler's freedom, and the second half is the compiler's constraints.
Yes.
Oh, okay, that's helpful too. But yeah, the one that I was really after was like, why the flipping of the?
Yeah, and the flipping comes because it both works in the math, and the code involved is trivial.
Okay.
There are other options.
Why it works in the math? That's interesting.
Yeah.
For ranges.
Yeah, and I'll show you. This is kind of a funny one. It's hard to believe that it works, and it totally works. And I very aggressively test on these things as well. So here's my dual. I just flip min and max. So the implementation of dual is one line, one short, easy line. Here's the implementation of meet.
Oh, there it is.
The meet says, take the min of the mins and the max of the maxes.
Well, do you somewhere detect that the min is greater than the max, and that's how you are detecting it? Is that how you detect its up top range?
Where is high? Here is high.
Okay.
That says your value is above the center line.
Oh, I see. Well, isn't that min greater than max then just so how you, I mean, you could just made a data structure with a flag saying saying that this is how would you call it, compiler choice
Yeah.
above or high, and instead
Yeah.
of doing min greater than max. So what min
Yes,
greater than
I
max
could.
really is doing is
I,
it's a
there
way
are
to detect that to describe that this is above the line or high
right.
without having any extra data.
Yes. This
Okay.
is all about how you implement these things
Okay.
and that retain the
I got it.
properties that it's symmetric and that it's range has a real range and whatever
Yeah.
other properties you need. So there's a implementation question. In
Okay.
this case, flipping min and max gives you this trivial implementation, but I could put
Yeah.
a Boolean flag here.
Really, yeah. And if you did Boolean flag, min would be less than max. Could be was and that's what was
Yeah, I
confusing
could
me. That's really
assert
what it
that
is.
min
Yeah.
was less than or equal to max. It could be equal if you're
Yeah.
a constant. I
Or
would
equal.
assert
That's what equal
min
to.
less
Yeah.
equal to max, and then
Yeah.
I would have a flag.
Okay. All right. Cool. Thank you. That clarifies it.
Okay.
That makes sense.
Yeah.
Very
Yes.
helpful.
Your question was really, this is all about ease of implementation.
Okay.
So I could have instead up here said choice of min to max. Like this is bool minus 1 to 0. It could
Yeah.
be choice of bool. And I could describe the lattice differently, and maybe that's
Mhm.
more intuitively obvious. Here in the floats, I don't bother. I put this little twiddle in front. Choice of floats.
Yeah.
All 64-bit floats, all 32-bit floats.
Yeah. Okay. All right.
Yeah. Anything else?
Nope. That's helpful. Thank you.
Yeah, no problem. No, I was
That's been bugging
very,
me for 2 weeks. I figured it'd be easier on the with the screen rather than Discord. So
yeah, fine.
anyway, thanks.
I'm maybe overly proud of that one, but it worked out in C2, many years ago, and people have lived with it without knowing what it does for 20, 25 years. Worked great, less filling. It tastes great, less filling. Yeah, fine. All
I
right.
mean, in theory, you could expose more of that to the language and allow people to have types that have explicit ors in it. This is a string or number.
String or number has other, yeah, as long as I get the lattice out in the end, I don't care. That has more implementation issues. I've done ORing logics in the past. You can really rapidly become not a lattice. And then you can discover all kinds of bizarre problems you have with not being a lattice. Like nil gets me to that problem. It's very easy to be not a lattice with nil. It seems like it'd be an obvious thing that you just have a null pointer. Well, of course you have a null pointer. Yeah, fine, whatever. You can call it option, you can call it whatever. But having one very rapidly will make you not a lattice without some very careful engineering, non-obvious engineering. So one of the things that happens here is I have strong lattice testing. And in AA, at least, I have some tools that lets me write a lattice down sort of in textual form pretty rapidly, validate it's a lattice. Almost always you blew it. You get rid of a bunch of extra edges in the description, so it minimizes how the lattice looks, and then you suddenly get to the point where here is the obvious non-lattice, and then you have to start sorting yourself around, and you play this whack-a-mole game, and you come to the fundamental knowledge that you can't have null by itself in the center as a constant of a lattice. It doesn't work. Very like, wait, what? How can that be? Well, it will work if you have null that is only part of one larger section, like memory pointers can have a null because there's nothing else but the memory. Well, that's fine. And function pointers as a constant function value can be a null like you would in C, but you can't have the same null used for memory pointers and function pointers without blowing the lattice property. And
Yeah,
that's
the
like, wait,
theory
what?
people in Lisp tripped over that a little bit, where they were like, okay, is the empty list equal to the empty dictionary?
Okay, yes. Same
And
would
if
be the
null is
idea.
null, then
Yeah,
yeah.
you would hit the same problem. So in AA, not AA, in simple, I hit it as soon as I said, I'm going to make a function typed variable and put a null in it. And the null token turns into the null memory pointer. And I'm assigning a memory pointer into a function pointer. And I flew a type error. I said, no, bad type. You can't put a memory pointer in a function pointer. Like, oh, null should be both. Not a lattice. Brutal. So then I need like a null function pointer as a syntax. It's like, no, this is stupid. So, I worked it out in AA and I made the fix over in simple. It's not obvious. And I
I
don't
mean,
want to
there
talk about
definitely
it
are
now.
languages that sort of bake the null into everything and be like, it's not string or null, it's an optional string. It's not dict or null, it's an optional dict.
Well, that's what I'm doing with
You
null.
just end up with a
Counts as
dedicated null for every possible type.
it's your optional for every possible type. It's the zero cost optional for every possible type. And then in simple, of course, I just test for it and guarantee that it's tested and you can't throw an MPE. And if you just say if, pointer, then that's the same as optional is exist or optional, whatever. It all works. All right, I just lost Aaron, which probably means one of his kids his wife wants help with his kids. But we can be fine. We can be done. It's time. If people want to see why null is not part of any reasonable lattice, I will show you how to fix it next week. It's not obvious though. It's heavy type theory. I think I've done heavy type theory with null in the past, though. I don't know if we want to repeat that or not. Fine. Anything else? Gonna be done. All right. Till we meet again. Nice seeing you, Simon. I do need a haircut. I see yours, but I need one too.
And just wear a hat.